One of several repeated themes here on the Modern Software Engineering channel is that progress is best made as a series of small, simple changes rather than as a series of big, complex ones. If this really is the case, then shouldn't small and simple be simpler? So why is it so hard for people to work and to think in these terms? I think that there's one big problem and three fundamental worries that tend to lead to this difficulty. But I also think that thinking about it like this helps us to see an obvious better way forwards and to genuinely make the small, simple steps simpler. So what is it that makes small, simple change quite so difficult? That's our topic for today. Hi, I'm Dave Farley and welcome to the Modern Software Engineering channel. If you haven't been here before, please do hit subscribe, and if you enjoy the content today, hit like as well and let everybody else know that you like it. I would argue, and often do, that making progress in small, simple steps goes way beyond the boundaries of software. Humans achieve remarkable things and solve amazingly complex problems and gain deep understanding of profoundly difficult problems, but never as a result of grand intuitive leaps of understanding, but rather always as a process of these small, simple, incremental steps. Unfortunately, we tend to like a good story and so get lured by the tales of discovery and genius, mostly because flashes of genius and inspiration make for much better stories rather than because that's how things really work. Descriptions of years of study and hard graft aren't quite as exciting. Moments of inspiration and even genius do happen, but they're moments and usually focused on small parts of a problem, not the whole thing, which come when people have thought about the problem for a while. When Archimedes leapt out of his bath shouting "Eureka!", that was because he had been thinking hard about the problem that he was working on. No doubt discarding ideas that wouldn't work and worrying about the bits that he didn't yet understand properly. But the whole problem wasn't solved at the moment when the water of his bath was displaced by his body. That event just gave him a clue, some inspiration about how to measure something that was otherwise difficult to measure. And by then, he'd already realized that that was the nub of the problem. He already knew, because of the time spent thinking hard about the problem beforehand, that he'd need to know some things that he didn't yet know. According to legend, Archimedes had been tasked with verifying that the king's crown built by a craftsman had been done honestly and used all of the gold that the craftsman had been given, rather than diluting it with cheaper silver and keeping some of the gold for himself. By the time of his famous bath, Archimedes had already taken lots of small steps on the journey towards solving the problem. He already knew, for example, that gold and silver had different densities, that a volume of gold would weigh a lot more than the same volume of silver. So given a known volume of each, he could calculate a value for the density in terms of the weight per unit volume. He had the crown, so he could measure it. And the interesting measures for this problem were its weight and its volume. So now all he needed to do was establish the density of the gold with an experiment, and then establish the density of the crown and see if it matched. If the crown was less dense than the gold, then the crown maker had probably cheated and was now in the king's bad books, which is probably not a good place to be with a king. If density is mass per unit volume, Archimedes needed to know the mass of the crown, which was easily obtained by weighing it, and its volume of that irregularly shaped handcrafted thing, which wasn't quite so easily established. Measuring the volume of the crown was the real problem then here. So sometime following this sequence of small, simple reasoning steps, Archimedes takes his bath. The bath wasn't really a moment of instant genius on his part, because he'd already taken all of these steps beforehand. Measuring the volume of the crown was just the last problem that he needed to solve in a series of already solved problems. And the bath just helped him to have an idea about how to solve that last step. Small steps. Let me pause there and say thank you to our sponsors. We're extremely fortunate to be sponsored by Equal Experts and Transfic. Both are very good friends of the channel and have been supporting us for a while. Equal Experts is a multinational consultancy built on applying the ideas and techniques that we talk about here to build great software for their clients. Both of these companies, though, offer products and services that are extremely well aligned with the topics that we discuss here on this channel every week. So if you're looking for excellence in continuous delivery and in software engineering in general, then do click on their links in the description below and check them out. I think that working in small steps is always fundamental to how we as humans work, even when we don't always recognize it as working that way, even when the steps are spread out over long periods of time. The approaches to development that I recommend are all foundationally grounded in making the most of this idea of incremental progress. And I'm convinced that that's why they work better than the alternatives, which they certainly do. I'm not sure if this idea, though, of progress in small steps is obvious or surprising, because while it seems obvious to me, lots of people seem to struggle with the idea of making change in small steps like this, and it seemingly worries them. So why is that, and what can we do about it? Maybe this is best tackled with some examples. I have two common problems in mind that people often raise when talking to me. But they are only examples. This seems to me to be a much more generic truth. My first example is centered around the question, how can I write a test before I've finished writing the code that I want to test? This is a common complaint from people who don't know how to do test-driven development. Their usual solution is to write the code first and only write a test afterwards, a coarse-grained monolithic approach to solving the problem. Some people even try to imagine their solution before they've written it and then try to write a test for their imaginary solution before they write the code. But both of these strategies completely miss the point of test-driven development almost entirely, and always result in a poorer outcome than real test-driven development as a result, mostly because they aren't taking small enough steps. My second example is when designing some software in general to solve some problem. All complex systems are created as a result of an evolutionary approach to development. Even systems built with a waterfall approach are really incremental. They're just slow and cumbersomely incremental, sometimes taking decades to evolve into something better. But evolve they do. This is always how engineering and science of any form really works. This is how we make real progress. We learn to do better and then we do it better. Fundamentally, if we want to do anything new, we're always starting out by, in essence, predicting the future. Because clearly we haven't got the thing that we want yet. So we are imagining some capability that we think would be good. That's one form of prediction. And then we're imagining how we might achieve that outcome with an implementation of some kind. And that's another kind of prediction. These predictions may be in the form of a test that defines what we'd like our software to be able to do, or maybe in the form of a design choice that we think will solve the problems that our software will face in the future. But they're all just guesses, maybe educated guesses, but still guesses. And so they may, any of them, be wrong. We're always starting with a guess, a prediction about the future. Guessing about the future is always difficult. We may always be wrong. That's true however we choose to organize our work, though we don't always think of it in that way. So being good at software development, or pretty much anything else mostly, is really about being able to achieve more good guesses than bad guesses. So what's the difference between a good guess and a bad one? Well, good guesses better fit the reality of the problem we face and move either our understanding of the problem forwards or add to the utility of our solution in some way. So bad guesses don't fit the reality of the problem, creating a bug of some kind, confusing our understanding, or probably both. They reduce the utility of the system. Predicting the future is rarely easy, but what is certainly true is that any prediction is less likely to be accurate the further into the future that it reaches. This is profoundly true, and so the best guesses, in the sense of the most accurate guesses, have a shorter time horizon. So if we aim to predict the future to achieve some outcome, we need our predictions to be good, and for that we need to organize our predictions carefully and make them over short time horizons. Fundamentally, what we need to know is what's the direction that we want to head in, what's our goal, what tells us if we're moving towards it, what's our fitness function for that goal, and how we can safely change things if we're wrong. So the first of these is really about having a clear understanding of our target. What's the problem and what's the outcome that we're aiming to achieve? The second is about how should we measure our progress towards that target, which is about picking a measure of some kind and using it to gather feedback. And the last is about being able to work incrementally to see if we are on track, on the right road towards our target, and spot soon enough if we're off track and to be able to correct it. Significantly, this is about making correction easy, giving ourselves the freedom to be wrong. The time horizon over which we gather feedback is crucial to minimizing the blast radius of our mistakes and also maximizing our chances of detecting them and fixing them. So we not only want good feedback, but we also want it fast. And that is what we really mean when we're talking about making progress in small steps. If we can learn after each step, there's more learning going on. If we take more steps, each step is smaller and simpler, and so that makes it easier to figure out where we are after each one. So how does all of this play out with our two examples? Well, test-driven development starts by defining the goal, by writing a test. We're guessing about what we'd like to achieve, but that's okay. We're always guessing when we design something. The first step in test-driven development, writing the test, has two objectives. Be clear about the goal and evaluate how we are doing when moving towards it. First, we define what we expect to happen. Given a precisely defined starting point when some event occurs, then what outcome is it that we expect? Check out our free test-driven development tutorial if you'd like to try TDD and learn more about it. There's a link in the description below. And second, more subtly but equally important, by forcing ourselves to start by writing a test, we are designing the external view of our code from the perspective of a user of that code, before we've even thought about the internal details of how we're going to make that code work. So we're getting the earliest possible experience of using our code. This is certainly a small step. This is the earliest possible feedback on how nice and how easy our code will be to use. If the test is hard to write, even at this stage, before we've written any actual code, beyond its external interface anyway, then our code isn't good enough, and we need to think again about its design. That's what I call small steps. Next, we run the test to see if it fails. We predict how it will fail. In effect, we define the criteria that we'll use to measure our code's success. If the test fails in the wrong way, our test is wrong. But if it fails in the way that we expect it to, even at this moment of an apparent failure, we're still making valuable progress in small steps. We now know our test is working correctly and asserting things as it should. In terms of our second design example, we won't have the capacity to hold the entire detail of the system in our heads. If you can do that, it doesn't mean that you're smart, it means that you're working on a simple system. So we need to find tricks that allow us to work on one part of the system without worrying too much about the other parts. My list of techniques for managing complexity, which I describe in my book, is my take on those foundational tricks. We use them to compartmentalize problems so that we can solve the bigger problem of the whole system in smaller, more understandable, more tractable stages. And rather like Archimedes before his bath, if we're smart, we do this in ways that mean that we can put off worrying too much about the hard parts of the problem until we're ready or forced by circumstance to deal with them. The first versions of Amazon and Facebook were simple PHP applications. The first version of Google search was certainly clever, but also fairly simple. No ads, obviously no AI search results, no images, all built on cheap commodity hardware, PCs and Linux. Over time, Google and the others grew as they learned more about what their users really wanted and were pressured to cope with ever-growing demand. They scaled in ways that no one predicted in the early days and came up with solutions that no one envisaged in those early days either. As I keep saying, it's always like this for any successful complex system. So our job as software developers is not to imagine all this stuff and predict every last way in which our software may be useful or how it will need to scale, but rather to create it in ways that will allow us to more easily change it when we learn to see things more clearly and what needs to change. The best way then is to work incrementally and use compartmentalization in design to isolate parts of the system that we don't fully understand yet from the parts that we want now. So once again, we're best to make progress in small steps. In this case, by deferring decision-making through design and having a good enough stance in testing that we can see when we drift off course. This is how all complex systems are built. So the smart thing to do is to work in ways that keep things easy to change. So using the tools to manage complexity and automated testing, in particular automated tests that specify what we want our code to achieve rather than tests that attempt to verify how it works, is vital to our ability to navigate towards our goals and to see if we're on the right track towards our target. You may notice that the small steps that I'm talking about aren't all the same size. But in general, I recommend that you always prefer smaller steps and seek out efficient ways to work with those smaller steps. You shouldn't be drowning in detail. It should be easy to do this. There are many, many smaller steps than this in test-driven development and in design in general. For example, ideas like modularity, cohesion, and abstraction are true at the level of functions and a few lines of code when you get good at working like this. But I hope that you can see how thinking in terms of setting the goal, deciding on the measures that you can use to monitor success, and getting that feedback quickly and reliably helps us to organize our work more effectively into these smaller, more definitive steps in the direction of progress. And so makes our ability to solve that really hard problem, that of predicting the future, much easier. Fundamentally, the big win is to treat everything as an experiment. Define the goal, decide on how to measure it, control the variables and iterate until you have an answer. This may take some thought, but the results will always be better than the alternatives. Thank you very much for watching. And if you enjoy our stuff here on the Modern Software Engineering channel, please do consider supporting us by joining our Patreon community. There are lots of benefits to that. And while I'm here, I'd also like to once again thank our existing Patreon members for your ongoing support. It's through people like you that we're able to continue making this kind of content. Thank you.